can you solve this geometry challenge? Here's the question. Let's begin with the circle. Now let's draw some segments like this. Now let's call this segment as A. This is B, C, D, E, E, and Q. Now, this angle right over here is 25 degrees, and this angle right over here is 35 degrees. And this angle AED measures X degrees, and this angle DQC is also X degrees. The question, what is the value of this angle X? So pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. Alright, the answer to this question simply equal to 60 degrees. So the measure of this angle X equals 60 degrees. And the question is, of course, how do we get 60 degrees? And here's the solution. And before we begin to our solution, let's have some concept about circle. Now, if we have a circle like this, and we have some chords like this, we created what we call an inscribed angle. And we have here the inscribed angle theorem. And using this inscribed angle theorem, we can say that these two angles are the same because they intercept the same arc. Also, these two angles right over here are the same. Now, take note of this shape, this butterfly shape. If we have this butterfly shape, and these two angles are equal, therefore, we can put this butterfly shape inside a circle. So that's the idea. Now, let's use this concept to answer this question. Now, this X, DQC is angle X. Vertical angles are congruent, therefore AQD is also X degrees. Now, here comes the butterfly shape. In short, we can put this shape inside the circle like this. And we know some informations in this figure. These two angles are the same, so let's call this as alpha. Now, from here, let's connect A and B. And again, we have this butterfly shape. So these two angles, we know they are the same, so let's call this as beta. Now, from here, let's connect C and D. And again, we have this butterfly shape. And we know for sure if this is alpha, the other angle is also alpha. Now, if this is 35, this angle is also 35 degrees. Now, let's have another concept. And this concept is about the remote interior angle theorem. So, the sum of two remote interior angles in a triangle, this is the two interior angle, is equal to the exterior angle. So, they call it remote interior angle theorem. In our figure, let's focus on this triangle. And take note, these are our remote interior angle, this alpha and beta. In short, this exterior angle simply equal to the sum of alpha and beta. So this is just alpha plus beta. So using this remote interior angle theorem. Now from here, let's call this angle beside x, let's call this as y. Why not? Because we will use again the remote interior angle theorem in this triangle. And now, the remote interior angles are 35 plus alpha plus beta and 25 degrees. In short, we can say that x plus y, or this interior angle, simply equal to alpha plus beta plus 35 plus 25 degrees. Now, simplify, 35 degrees plus 25 degrees is 60 degrees. And we have an equation that says that x plus y equals alpha plus beta plus 60 degrees. Now, another concept. Let's have the cyclic quadrilateral. If we have a circle like this, and we have a quadrilateral inside of it, and we know the opposite angles of this quadrilateral adds up to 180 degrees. So, if this is theta, this exterior angle is also theta, because this angle right over here is 180 minus theta. This is just straight line. Now, here comes a quadrilateral. Let's focus on this. And we know for sure, we can fit this figure inside a circle because of the shape, butterfly shape. And so, this alpha plus beta is equal to this angle y, this exterior angle y. In short, we can say that y equals alpha plus beta. Now, using these two results, we can now find the value of x. Because we know alpha plus beta equals y, so we can replace this alpha plus beta with y. Now, subtract y on both sides. We cancel out y, and we get that x equals 60 degrees. And that is our answer to this question. Therefore, given this figure, then the value of this angle x simply equal to 60 degrees. And as always, we are done.